If someone can check the audio on YouTube, please. Kazi, when you want, you can start, please.
Yeah, I'm just checking if it's.
Kazi.
It's working,
Yeah, it's working.
Luca.
Should I start or someone else want to say something?
No, you can start.
Okay, so hello everyone. Myself Kazi Sohrabuddin. I am currently working in the AI team of Net7, and today we are gonna present our latest work based on fine tuning for a specific client with some specific requirement. And we are naming this Can a Tiny AI Speak Factory. We will go through the full process, what we have done, what we will do in the next, and I will try to make the journey as smooth and as funny as possible. So what we are aiming to do is, for now, for this project, we can say, we have divided this part into the full steps, like the problem, what is our objective, what was our objective, and then dataset, baseline. These things we will see in the later. So what was the problem actually? So as you see, as a human, you can ask, okay, I just want a simple answer, but your database, he doesn't know your language. He has to be in a specific way, which is SQL. So what can we do? We can write SQL, but it's not feasible for a normal human to remember all the SQL grammar and all the things to write. So this is our problem, that we need something who will convert our thing, translate our thing into database thing. But there is a specific requirement from the client, that is, we cannot use cloud. As a result, we need something that can run locally with a small GPU, CPU, or which is feasible actually for locally used. And if we want to do something by, those AI stuffs, without locally, we have to be from cloud, which is just like this robot. Do your work. But at the end, we need something. And we have gone through some small models, which is, you can see in this models part, we have tried Queen 0.6 billion, 1.7 billion, and 4 billion. But just to give another reminder, that we had the client requirement must run locally, no cloud API. So our objective was clear, that from the client side, we need something small, precise, and doing good SQL query, but locally. So I hope I'm clear with the objective. And then this is our journey. So I have divided it into 4 steps. There is baseline, which is the raw model without fine tuning. And then the SFT, which is supervised fine tuning. And then if you see, there is plus thinking. That means there was one supervised, which is without thinking. There is another supervised, which is with thinking. So this proves actually with thinking it's performing better, or with thinking it performing better. And then the GRPO is just like algorithm of reinforcement learning. So we'll talk more about this later. And for any problem, the first thing is, what about the database? What the data set? What are we gonna use for the model? On which things we're gonna train the model? So for data set, I literally, just like the image, I literally hammered Heiko, like with a lot of rules, with a lot of regulation, that I need this type of data, this type of query, as I don't have right now the true conversation, the true questions from the client. So I have to go for a synthetic data set. But I tried to regularize those data set in a way that it close to human. So the way we ask question, the way we give information, And as a result, I had to do a lot of hard work to convince Haiku that okay, I need this type of specific thing. You cannot just generate a random thing. So I literally followed this one, hammered the cloud. And then not only the creation, I also gave him the score, that which query is the precise one, the best one, and which are the working fine one. So the LLM score is that part, and uh, it's so small that we have only generated 1,000 queries and question, and between these we have 859 in train and 141 in eval. So it's very small for a model. So we will talk about that later also. What is the impact of this small data set? And then let's start our model. So this is the baseline where we have not trained anything. We just call the model from Queen and just give him the question with the schema that, okay, this is my schema. Now answer me this question. And if you see the result, if I give him the thinking, he perform a little. But if I don't give him the thinking, it's literally zero for every model. So this is the thing that it's kind of base thing. So when someone trained like Queen, they trained Queen, the owner, not us. So they used it with thinking. As a result, when I ask him that, okay, give me the answer without thinking, as I have not trained it, it cannot start without thinking. It just ignore what I have said. So it always start with thinking. As a result, I cannot get the SQL. So this is the reason why we are getting zero for all the model for baseline. So with thinking, it does a little, but without thinking, completely messed up. And then I have said, okay, what if we just fine tune something and let's see what happened. So for fine tuning, just to give you a small explanation or description what is this stuff. So fine tuning is more like your student is practicing the examples with the answer, and he is seeing everything that okay, I can get this type of questions in the final exam. So to just to make the environment a little light, I have used this memes, which is perfectly describing what is fine tuning with the, if you see the book and the brain who is learning. So this type of thing is more like, if I train a model based on my um, local thing or collab or somewhere, if I train the full model, it is very hard for hardware to carry this weight. So we use LoRa. If you see this, so LoRa is more like, he makes the training smooth. He makes the training light. He doesn't update all the weights of the model. So he just push a matrix and then update all the things, so which is very light to run, which is very easy to run. So we went for LoRa, and I think, yeah, the training was very good actually. Like, I didn't have that much hassle for that. So let's now think about what we did with the fine-tuning model. So we were thinking two way. One, we should fine-tune the model without thinking, and let's see what it does, because earlier we have seen if we just give him without thinking, he just does zero. But if we train him that without thinking you can answer, maybe he returns us something. So this is what we did. We didn't give him the thinking. The reason, thinking means the reason behind the SQL. So every model just think first, they make the reason first, and then they write the query. So we tried to avoid, to ignore that reason, that don't use this, strictly give the SQL. And as now we have trained the model without training, without, sorry, reasoning, now he can give us some result, and which is not pretty bad actually. For the smallest model, we get 47.5% accuracy. For the 1.7 billion, we get 57.4, and 4 billion, we can get 54.6. If you notice something here, 4 billion is performing little less, because 4 billion is made of to solve complex query, and without thinking to solve those queries, pretty hard actually. So without thinking, it's good, it's performing better, but it's not up to the mark what we want, what we expect. So we said, okay, let's now train with thinking, see what's happened. So now he's just doing a lot of math, a lot of thinking. He can solve those complex stuffs also. So we have said now here is your reason and here is your thinking. Train yourself and then answer me with thinking. You can do that. And this time, if you see the result between without thinking and with thinking, it's actually a big jump, and big jump for hard query. There is differences between query, that easy query, medium query, and hard query. So easy query is easy for every model, medium is okay for every model, but hard is very hard for every model. So we also kind of categorize that if any model doing good in hard queries, that means this model is very good actually. So if you see this 4 billion model, now with thinking, is actually performing very good. 44% jump for hard query, not for accuracy, for overall, for only hard query. And overall accuracy is this one, 79.4. So we are thinking that, okay, 4 billion is good actually with thinking. We can get close to 80% accuracy, and it's really good. And for hard queries, big jump. So, and then my team lead, Alessandro, he was saying, no, we are not satisfied. Let's try another thing. So I said, okay, let's go. And we tried the GRPO, reinforcement learning, which is um, pretty hard actually. And for that, for this GRPO, it takes a lot of time, a lot of GPU, CPU, because it train also, it gives the reward that you are doing good. So in the time of training, it giving you the result, which is, it has to go with the database, the data set. It has to see what's happening. It has to see the answer you are generating, the things you are training on, is it actually validating it. So he's doing a lot of stuff. He's also generating, he's also marking your result. So I will also show in a simple way later, but this is what I was talking about, that if we go for some big model and we do some fine tuning with thinking a little bit, so this is what we're gonna waste on. So if we use a 100 collab CPUs in GPU, is easy, 1 to 3 seconds. This is easy to wait. So for each query, if I write a query that, okay, what is this, it will take 1 to 3 seconds to answer your question. But if you use T4, the non-paid free version, this is what will happen to you. You can just wait for a long time, for 20 to 30 seconds. And we never know what will happen after 20 to 37, but there will be answer. So it's pretty hard to wait for that time only for one question. So we always say, okay, we should use some better, and we will talk about this later also, with which type of GPU and CPU we can use. But for now, we can go into reinforcement learning algorithm, which is GRPO. So just to give you an idea, GRPO was invented by DeepSeek AI recently, 2025. So what it does, it it is different actually than other things. So we will talk about this also in the next slide. But for now, so reinforcement learning is more like you are learning during the training. If you make a mistake, someone will say, okay, you are doing it wrong way, this is the right way. So to understand this easily, I just use this meme. You can understand the human is trying to give him the idea that how you should hold the range. So, and in a way, at the end, he learns, okay, I got it. So if I go how and why, so there are a lot of algorithm for reinforcement learning, but why did we chose GRPO? If you just see, I have mentioned some algorithms. So PPO, DPO, these are also some reinforcement algorithm. But the problem, The problem is there is a critic model. Critic means if you think the human. So another model is the AI model. So there is two model. One is generating what to do, the query, the answer, and everything. And then the critic model, who is marking this output that, oh, you're doing good, oh, you're doing bad, or you are doing something medium. So this is the thing we hard code say in the GRPU that there is no critic model. We write what should be the mark. As a result, what does the training time, the GPU, CPU, it saves a lot because if there is two model running and if there is one model running, obviously the one model running will be faster and most saving. So what we did for GRPO, we said if you do things good, you will get good mark. Good mark means you are doing good. So in this way, GRPU is different than other models because it's saving you time, GPU and everything, and it only use the mark, hardcore mark that okay, this is my reward. So I will learn by this way. But other algorithm they use critic model, which is a lot of stuffs to go back and forth. And for this GRPU, we were usually using the fine tuning version as a base. So just to give the idea, we are using a already trained model for the reinforcement learning for GRPO. So which was our already trained model SFT, which we trained and we have named the version V4, SFT V4. So we are going to train our latest GRPU model based on this. As a result, what it does is not starting from the beginning. He already has a setup, he already has a value level that I will start from there. I will not start from the beginning, from the zero. So we trained two model with the same style but in a different way. If you see GRPU v2, GRPU v2 is actually training on SFT v4, which is supervised fine tuning latest model. And then we got the GRPU v2. But I saw the accuracy, which is if you see here GRPU v2, 87.2%, which is pretty good. We were happy that okay, we got our thing, we got our model, and everything is good. And then later, I was thinking, I'm not I'm I'm not I'm a little bit skeptical that what if we try another time and what if we get 90%? Because every time if you see from the childhood, if we see something 90% up, which is it's very good actually. So it's more like a human thing, like I'm not satisfied yet. So without thinking more, I was like, okay, let's just try last time. What would happen if I follow something like this? I want to train a new model, which will I name GRPU v3, but this time I will use the fine-tuning v4 plus the GRPU v2, which was our latest GRPU version. So in this way, what he is doing, he already has a baseline. Then again, another baseline, which is GRPU v2. And now if I train something new, he already knows what is these two model making the mistake. As a result, we can focus on those area. So I was trying to, okay, let's just change some value and this, and then train the GRPU v3. But the main difference is this time I'm saying if you do something wrong, I will not give you any mark. As a result, I'm strict with him that okay, go try, but there is no partial mark. You have to get it right. And as a result, we can see a big changes. If you see here, for the easy query, V3, 100% right. For the medium query, V3, 88.9, which is similar to the V2 version. This is the reason because earlier in V2 version, the most behind one was hard query. So in V3, he actually focusing more on V more on hard query, not the medium one, because medium was pretty good already. So he made mistakes on hard. Now he actually focusing more, giving more if effort on hard one. As a result, you can see the big jump from 78 to 90%, which is crazy for hard query, because this is the biggest jump we could ever had. 90%, a trademark. So I was saying, okay, this is actually good. And if I show you the total result now, our the toppest one is GRP V3 with 92.9, close to 93% accuracy, which is for this small model crazy. To me, if I say, it would be like, when I saw the value of this accuracy, I was like, wow, crazy. Kazi, you did a good work. So this is actually very satisfied result for me also. And then the GFV version V2, which is close to 88%. And then lower than that, we have the fine tuning version, which is close to 80%. And then the baseline, which was not trained, 38%, which is okay, good if it's not trained yet. So this was our total training and all the result we got. So now, if I just explain a little bit about what's happening on which type of query. So I already told you the hard query, it was the most difficult one. For easy and medium is always okay, but for hard, if you see the result, it's always not good in terms of other two. But in GRPU version 3, hard is doing pretty good. That means we can expect in real life this V3 version will work actually better than any other version in terms of queries and making answer. But still, now the question, as we used some specific person who can ask specific question, just to give you an idea, there might be some customer analysis, might be some production engineer, real operator. This type of role can ask different question. And we have seen during the training and every time that this quality specialist, he's actually not performing very well because he had some complex query. His work, his asked question was little bit complex than other user. So I saw that, okay, now in the V3, he's actually performing better. So if you see the result in V2, it was actually 68%, but here 88%. So I was pretty sure that, okay, this is performing this model V3 is performing good in every perspective we could analyze for synthetic data set. We don't know yet the real life uses, but which is close. I have seen, I have tried to make it as much as real possible. So I have tracked everything, every person in every table, which one is doing what. And at the end, we say, okay, VV3 is doing really good. Still, it's 92.9. What's happening with that 7%? As our data set is little, just 1000, within 1859 for training. So we can say the data set is still a little, which makes the model sometimes hallucinate. So he sometimes makes some column name which is not in the data set. So this is things we can fix with bigger data set, real life data set. So it won't be a big issue. So we can always train the model, the latest one, with real life stuffs, which will make him more better, more better. We can push him until he is in the ceiling. So this is what I think for me, that this 7% actually because of that area, and we can always train that. So let's go in our last steps. So as a recommendation, what would we say? I would say that if there is a proper hardware to host the model, I would say V3 is the best one we have for now. So we can host this model. But if we don't have that type of hardware capacity, we can also try 1.7 billion, which is 83% close to accuracy. This is good actually. So we can also try this one if there is no proper hardware. but we don't recommend to use 0.6 billion, which is too small, and his accuracy is 56%, which is like a coin. You can get maybe the right answer or maybe the wrong answer, 50-50 chance. So we don't recommend that. And what would be our next step, our next thinking? So I was just going through some GPU, that which GPUs can actually host the model. And I got that RTX 3090 and 4090 is a good capable one for this, because it has 24 GB of VRAM, which is very good because we need only 12 something. So it will still use only the 50 or 56% of the VRAM. So we are in a safe zone. And this is what we are thinking now, that where can we deploy, what can we do, can we only use CPU? So this is the stuffs we will think. For the client side, we will just get the confirm information from the client, what we can get, what the capacity and what are the options, then we can actually think of this part. So for now, this is what we have done for this project. I have tried to take you through the journey in a simple way, but I'm pretty sure some of the information maybe not properly explained because of time and everything. So I would love to explain it again if someone wants to know that, okay, what is this part, what is that part specifically. We can have the conversation later also. So for now, thank you guys. I hope everyone is mute. Why?
Yeah, no. It's thank you a lot,
Thank
Kazi.
you,
I
Kat.
really appreciate your talk. Very interesting stuff. I see when you're talking about it, you are kind of enthusiastic. So I think
Yeah, I love that.
you love to do the kind of things. I'm really happy with the results, of course. I will see how it works in a real case scenario. I mean, now you are working with synthetic data, if I understood well.
Yes.
So, so from my point of view, very interesting. I have one question, if it's possible. Why have you used Haiku to generate the synthetic data and not a better model?
Okay, so we have tried GPT, GPT 5 and GPT 5 Mini, then Grok, then Cloud 4. Sonnet 4.6, and then the cheapest one was Haiku. So I tried everything. I think 5 model. I initially generated 10 queries and question. Then I saw what is the cost, what is the quality, is these questions and query returning anything from my data set. So after judging all these steps, I saw Haiku is performing better than any other model, because he is strictly following the rules I set. Like I was hammering. So I was hammering all the models who was listening to me properly. Haiku. So I said, okay, he's also cheap. Let's just generate with him. And Ale gave me the idea that I think you should train all of these and then see what happens. I said, okay. Then I was like, okay, let's just use the Haiku. It's the cheap and also it's listening to us properly.
Okay, thank you.
Yeah, maybe I have a question as well. The question is if you have tested something ambiguous, like ambiguous question, out of scope requests, or maybe SQL injection attempts, because in production, this is probably one of the first things that will happen.
I'm not sure if I'm getting the right question, but is it about the conversation in real life? How will this work with this model? Is it like this?
Mhm.
Yeah.
So just to give you a small idea, Ale shared me a conversation where we had some real life conversation. So when I was making the rules that I need the query and the question in this specific format, I use that conversation. So the query we are using now is close to the real life one because we are motivated from that. So I hope because until we go for the real life production, it's not possible just to guess, but I hope it will work fine. Yeah, Ale.
Yeah, just for give you some more context about the task, we start from the text-to-SQL because the first time that Valmet proposed us to experiment a little bit also with this kind of model, our problem was, okay, I know that the small model are problematic also to manage a complex conversation. So in our idea, our first task at the moment was to show if we have some kind of data, okay, that are good quality data, we can train literally a model for converting the right question in the right query. Okay. So at the moment, the fast answer, let's say, at the moment, if you throw literally a question that is totally unrelated, maybe the thinking can handle this kind of question, but in the training data, we doesn't insert any kind of data or query out of context. So at the moment, is not capable of, I think, because we doesn't test about that kind of thing, but is not able to handle this kind of query. So at the moment, I think that the answer that we receive is another query that is totally no sense query, literally throw in the database. But also this is an important lesson, for example, for the small model. If we want to use a small model for automatizing some kind of task, there is more design process in the building of the application. So you have to reasoning about what are the tasks that you have to deal with inside that kind of context, and what kind of task we can use for training the LLM. If you have one single task, you have a good possibility that the model can learn that kind of pattern and handle also in production that kind of pattern. If you start to have complex conversation, different tool call, reasoning, advanced reasoning, in that kind of situation, for the moment, this kind of model doesn't work. So in this kind of, maybe there are possible other way that we can handle this kind of scenario. For example, create different, because at the moment we have an adapter that you put in front of the model, and then the model adapt to this kind of task. So you can have multiple adapters that are specialized in different kind of task, and a router in front of all this kind of adapter that can literally choose what is the best path for answering to the user. But still, with this kind of model, you can have GPUs that are less powerful, but still you have the problem that, of course, you have to understand what are specifically the tasks. You cannot just throw a prompt and ask to the LLM to solve that. So that's the thing, and the answer is at the moment, I don't know if you have any other element to add, Kazi, but at the moment I think that this cannot is able to handle this kind of queries out of context.
So as well, if you change the schema, maybe if you add a table.
Exactly. Yeah, it depends. Yeah, because at the moment, of course, this is another important lesson. At the moment, we are specializing on a specific task and on a specific system prompt. That's the idea. Because if the task was to build a text-to-SQL, so a model that generically can handle a specific schema that I put inside the context and answer properly to the question, is something that at the moment, a model of this size is quite impossible to handle all this kind of possible complexity. In fact, if you can see also online, Snowflake makes different tests about that, and the base model that they use was 32 billions of parameters, the starting model. So it's a different task, a different manner, and in this kind of task, this kind of model so it's very difficult. They can handle with a good level of quality this kind of task. So the idea with this model is this one. So you have a specific task, a specific thing, a context that is well defined, and then you teach to the model to handle the different possible scenario in that specific context and task. That's the thing.
Yes, I think Gabriel has something to ask.
Yeah.
Yeah. So first of all, Kasi, shout out because it was a very good presentation. It's also easy to follow. So very good job. No, my question was a little bit related to what Alessandro says, and it's about the production use of this model. This model is fine-tuned, let's say, to handle queries, but in the production use, I imagine that a user could chat like normally with a model, and then maybe this will be used as a second agent that handle the query, for example, to explain my question in a easier version. Maybe you can start chatting with a chatbot, and then when the main model, which is not a fine-tuned one, but it's more like a general one, and that is it's a specific query for a specific user personas, can query another model via tool or via sub-agent that handle this kind of specific query. Is that observation right? Do you have something to?
Yes. This is the whole scenario what we are thinking. I mean, from the beginning, Ali said there will be a primary model which will filter all the question, which will do the conversation with the client. He will ask the necessary things, and then he will send those info to this tune model. So this is what the full scenario. So we will also think if we can make the first agent as a locally, because right now I think they're using Sonnet 4.6. So we are also thinking of to make it local. As a result, we will have two local. The first one will do this conversation, and the second one will only generate the query on those specific question. Ali, you want to say anything?
Yeah, I agree totally with this kind of approach. Is a good approach. That's the idea, of course. So to specialize specific sub-agent with small model or adapter in a specific task, then there is an orchestration that is more general, and the idea is that this orchestrator must handle the query, understand what is the best agent to answer directly, or the combination of different agents for answering directly to the user. And more of that, you can train also the orchestrator to understand what is the best possible path to answer to the user. So are different adapter with different specialization, specific task specialization that you can handle also complex task, but dividing this task in small little tasks that correspond to a specific adapter for the model. That's a possibility. At the moment, for Valmet, this is more like an experiment, because from a manufacturer and industrial point of view, they have a lot of interest to have a small model in their machine for handle this kind of task, because of course, with a large language model like ChatGPT or other kind of stuff, of course, it's easier to implement this kind of task and this kind of flow. But still, in certain situations, also ChatGPT doesn't understand very well what is, for example, the right way for querying, for example, the data. So still, in any case, okay, cannot handle complex conversation, okay, but the fine-tuning and the reinforcement learning are still good kind of approach for specializing also in a specific environment, the model for handle our task, let's say, not just prompt engineering. And also, let's say, is more software developer job, let's say, in that sense, because you are not writing string, evaluating if that string works or not, but you are also handled with, for example, the data that you are using. And more, and the other lesson that we learn about that in many cases, the client doesn't have the data for feeding this kind of model. So, but we have powerful model like Sonnet or Claude or ChatGPT that could be used for distilling, for taking the data, for feeding this kind of LLM. And maybe the best approach with all the clients is to start, for example, with the larger model, producing data, taking the data, and understand what are the user scenario. Based on that, augmenting the data using maybe large language model, property large language model. Once you have enough data, you can put in production and then collect more data, let's say, and then with this data, fine-tuning another time the model that you have. It's a complex process, but if we can sell literally this kind of pipeline to a client and explain very well to a client what is the process and the flow for create a sort of independence from the point of view of data retention, I think that is feasible. But we have to work a lot more in this sense.
Very interesting. Thank you for your answers.
So thank you guys, thank you Kazi, good work, and see you and bye bye.
Yes, if you have any question, take apart Kazi in the office and ask.
Yeah, I just said, if anyone wants to know anything more question, please, we can have a discussion later.
Or if you want to experiment with Cola, because we have a lot of credits at the moment.
Yeah.
So if you want to experiment a little bit in training data model, you can ask.
1400 minutes, so we can do a lot of things.
Okay, see you. Bye bye.